Welcome, I'm Erik Gross. This is our Intro to Python class, and this is me. I'm a senior level software developer with decades of experience. I was in the Navy for about 6 years, was an electronics technician and a nuclear reactor operator. And that's where I actually taught classes for the first time as a young man. Yes, Clive, we're going to get a copy of the recording. We'll share the links for that at the end of the class. Yeah, it was in the Navy that I first found out that I can teach and enjoy it. I'd never done it before then. And the Navy volunteered me to teach and found out I loved it. I'm also the co-founder of the Tech Academy, and we'll give you plenty of information about the school tonight. All right, so a couple basic guidelines for the class. We have an assistant in the chat. You may very well see Gracie interact with you in the chat, right? And she's there to monitor the chat, answer questions. Please be nice. Gracie will remove you if you're a problematic student, although that just hardly ever happens, so I'm really not worried about it. I do want to stress that the class will be challenging, not super challenging. I just want to point out that you might run into challenges, and that part of the learning process is working through those challenges. So please use the chat as needed. I monitor it all the way through and try to answer as many questions as I can as we go. One very important point about that, and please ensure that when we're writing out code, which we will be in a little while, when you're writing out code, be sure to type the code exactly as written. And the reason for this is a misspelled word or a missing symbol or even something capitalized that shouldn't be capitalized can result in errors in your code. Also, please make sure you're in a distraction-free environment and can focus on the class so I don't lose you. Finally, if you do fall behind, don't worry about it. Like if you get lost or you can't keep up with writing the code, please stick around and listen because you'll still learn a lot. As I said, there will be a recording of this. We put up on YouTube either later today or tomorrow, and we'll get you a link to be able to access all of our free YouTube videos at the end of the class. Finally, you're going to get a full copy of the code for the game. You know, we're building a tic-tac-toe game where we're showing like what does it take to build one of these games and how do you relate that to the fundamentals of programming. We're going to cover all that, but you're also going to get a copy of the full code, and you'll be able to play the game, and you're going to be able to tweak it. It'll be your copy of the code, okay? And I think I already mentioned this, but you're going to get links at the end, not just to our free YouTube videos, but all of our future events, other resources. So I think everybody's comfortable with using chat. You've all done it so well. If you have not yet done so, please drop into chat where you're joining us from. I'm down in Louisiana, not far from New Orleans. Drop into chat if you haven't already. Where are you joining us from today? Dan's joining us from Portland, Oregon, my hometown for 30 years. Excellent. All right, good. So welcome. Glad you're here. Here's the agenda. We'll have a short explanation of the Tech Academy, and then we'll write code. While I do try to answer questions as we go, you know, while we're writing the code, if we have time, we'll also have a brief Q&A session at the end. Then we cover some information about our boot camps. And there is a free gift waiting for you. So please stick around till then. And it is a nice gift, something that's valuable and will send right to you. A whole class should take about an hour to an hour and a half. So who are we? Well, we're the Tech Academy. And what we do is we provide boot camps. Boot camps are intensive technology certification programs. They're designed to prepare people for entry-level positions in technology. Typically, a boot camp will last anywhere from around 3 to 6 months. And boot camps focus on practical modern skills. In other words, what do you need to break into tech and get that first job? Now, at the Tech Academy, we've been offering thorough, budget-friendly, flexible, trusted coding boot camps for over a decade. And the certification programs we have are cost-effective, they're self-paced, they're fully online, and they're tailored for beginners with no prior technical or coding knowledge. Now, it's great if you arrive with some coding knowledge. I saw in my question earlier that a good number of the people attending tonight have some coding experience, but if you don't have any, you can completely get through our program. The programs cover in-demand skills, thoroughly, desired by the tech industry. They're endorsed by stellar online reviews. We design them to fit around your personal schedule. They're really flexible. And we want to prepare you for a technology career with a really well-rounded toolkit. If you're not familiar with this, The national average for tuition in America is around $13,500 for a boot camp. We're under the national average. We have boot camps starting as low as $5,980. And finally, I want to read our mission statement. The mission statement of the Tech Academy is to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry and whose actions raised industry standards and surpassed client expectations. That's what we're all about. All right, now, let's cover a few basic terms and concepts. First, we'll cover the concept of a program. A program is just written instructions that are entered into a computer that make the computer perform a certain task. That's all a program is. And we write these instructions in a programming language, which is an organized system of words and phrases and symbols. And they let you communicate with the computer and tell it what to do. Programming languages, again, are what we use to write computer programs. So as a verb, coding just means that action of entering in those instructions, entering them into the computer to make it do work. And then code is those instructions themselves. In a little while, you'll be writing instructions. You can look at the screen and see all of your code, your instructions. And then, of course, Python. This class tonight is centered all around Python. And Python is a really popular and great computer programming language developed about 35 years ago by this fantastic engineer named Guido van Rossum. And a couple of the cool things about Python. When you read it, it very much resembles common English words and speech, which makes it easy to understand. And it's very flexible. You can use it to create all kinds of computer programs, from mobile apps to websites to games and a whole lot more. So Python is worth learning. All right, now, what we're going to cover right before we start writing code is actually some of the most foundational and important knowledge about writing computer programs that you're ever going to find. Even though what we're about to cover on this slide will seem very simple, it's very valuable. And if you understand these 5 elements that are in any computer program, learning to program or learning a new programming language will be even easier for you. So what's the first fundamental element of any computer program? It's called an entrance point. All this means is, what's the first instruction that happens right when you, quote unquote, turn on a computer program? Right when you run the program. There has to be a first instruction. And this is valuable for a couple of reasons. One, when you run that first instruction, it tells the computer, hey, this program's starting, and I need you to do something really important for me. Inside the computer, I'm tapping my desktop right here. Inside the computer are storage devices where you can store data that your computer program is going to work with. They call them memory devices. They're little physical devices, and inside them are millions of little storage locations where data can be stored, right? Well, when you start a program, the computer will reserve a big chunk of those locations just for your program to use to put data into it. So that's one reason why that first instruction is really important. But that just helps the computer. There's another reason that's actually very important to you as a computer programmer or software developer or engineer, whatever you're called. There's another thing that's really important about an entrance point. And here's what it is. Let's say you break into tech and you get your first job, and that's awesome. And you join a software development team, and that team, pardon me, that team is responsible for maintaining a really large computer program that already existed before you even got there. Now, I'm sure you can see that it's going to be kind of important for you to get familiar with that computer program, for you to start reading through it and see how it works and what it does. And knowing that there's an entrance point and how to find it, knowing that there's a first instruction somewhere in that program is actually really helpful to you, because the best way for you to get familiar with this new program, or it's new to you, is to find that first instruction and just start stepping through all these written instructions and understanding what that program does right from the beginning. Yeah, I think you can imagine that if you started studying this program somewhere at random, halfway through it running, you'd lack a lot of context. So knowing there's an entrance point is really valuable. All right, second element of a program, called variables. Now, variables, it's a relatively straightforward concept. It's just pieces of data your computer program needs to keep track of. But the important thing here is this is data that can change while the computer program is running. A typical example, like if you're playing a video game, might be your score. If it's like a first-person shooter and you're keeping track of points or whatever, you're going to have a variable to keep track of the player's points. So that's another fundamental element of any computer program. The next fundamental element of any computer program is the ability to do what's called control and branching. Now, all this is a way to create decision points inside your program. If this, then that, like that kind of a concept. Without this ability, your programs are going to be of not very much value and help to human beings. And so this control and branching thing is really important. We're going to build these tonight in code. The next element of a program that's super important is what's called subprograms. Think of these as programs within your program. They're just sets of instructions that can be called on and repeated over and over again really easily. And again, you're going to build some of those tonight, and you'll see how valuable they are. And finally, there's an exit point. There needs to be a final instruction. There needs to be a way of telling the computer, on which this program is running. There needs to be a way of telling the computer, hey, this program is going away. It's closing. So anything you were doing to support this program, you don't have to do anymore, especially including what we talked about earlier, where when you start the program, you're reserving some of that storage area inside the memory storage device. No other program can use that area as long as your program's running. So when your program stops running, the computer can release that storage area for other programs to use. So these are the 5 elements. Now, you don't necessarily build your computer program with these exact elements in an exact order. It's just that any program in any computer programming language makes use of these 5 things inside it and no other things. These are the only things that are ever inside a computer program. And knowing that and understanding each of these 5 things can make it a bit easier to learn new languages and to build programs. All right. Let's move on and we can start writing code. Now, first place we're going to start is where we need a place to write our code. So to make this easier in these classes, rather than having you all install some sort of program on your computers to write your code, we use a nice handy online code editor, a place where you can both enter your instructions and then run them to see what happens. So this is the link. And Gracie, if you can drop that into chat, that'd be awesome. This is the link to an online code editor. There it is in chat. Go ahead and click on that. I'd like everybody to click on that link, and it'll open up a tab in your browser, and you'll see a code editor. Now, give a second for everybody to do that. And here's the next most important thing. Before I switch to this next slide, I want to explain what we're going to have you do. I want you all to be able to have me writing code side by side with you writing code. Now, if you have 2 monitors, it's pretty easy. Just put me on one monitor and your code editor on the other. But if you've only got 1 monitor, here's what you do. You'll want to put Zoom on the left. Like right now, my Zoom, of course, I'm sharing my screen, so it's showing the slide deck, right? This PowerPoint slide deck. You're going to want that on the left. And on the right, you want your browser with that tab that's showing this code editor you just opened. So I want you to set up your monitor so you've got me on the left in Zoom and your code editor on the right. For help on that, Zoom sometimes is a pain to resize and move around. If you click on the word Zoom meeting, a little restore option pops up. If you click on that, it'll let you resize and move the Zoom window around. So hopefully that helps. And for a browser, in the top right, you'll see this little symbol. It'll come back in a second. See this little symbol right here? It looks like 2 squares. When you click that button, it lets you resize your monitor, or your browser. So use those controls and set yourself up so you have me on the left and your browser on the right. I'm going to give people a second. I'm going to take a sip of water. All right. So now we're going to move on to coding. So first, let's look here. Of course, my code editor has a bunch of stuff from my previous work in there. Let me erase it. First thing I want you to do is just erase all the code that's inside your code editor. Now, this next thing, I'm going to show you the game that we play. You'll get all this code later. Don't worry about it all for now. And so I'm putting in the code for the full game. Now, there's a fair amount of code right here. Don't worry about what it all means. When we're done with this class, you'll be able to understand a lot of what's going on here. But this little play symbol up here runs the program. So I'm going to run it. And over on the right, I'm playing tic-tac-toe. So I've got a grid, A, B, C, and 1, 2, 3. So I'm going to go in the top left, which is A1, and it's going to print out the grid. And then the computer I went with A1, the computer went with C3. So I am going to, let's see, how do I beat this computer? I'm going to go A3. Oh, see, it's not very smart. So I'm going to go A2 and I'm going to win the game. Okay, good. So that's the game. Okay. Now, again, don't worry about all that. We're going to look through all that code in detail. Here's what we're going to do. Erase all that. What we're going to do is we're going to accomplish two things at once. The first is getting you familiar with some of the fundamental, instructions in Python and some of the basics about how to write a computer program in Python. But the second thing we're going to do at the same time is we're going to show you how those 5 things we talked about a few minutes ago work. The 5 basic elements of any program. How do they work? We're going to use Python to illustrate it, but you're going to learn these 2 things at once. So the first thing we're going to talk about, hold on a second, there's a question. Oh, Farouk is asking about mic and camera and all that. In the way we have Zoom set up right now, it's only through chat that you can communicate with us, but I'm watching chat pretty well, and so is Gracie, okay? With these classes, sometimes we get a huge number of people, so we don't open up to voice chat. We do have a service that I'll talk about later on, Farouk, where it's much more in-depth, and there is full, camera and chat and everything with me, but we'll talk about that later. All right, so let's actually start writing some code. We're going to put our first instruction in, and it's going to be a simple Python instruction to print something over here on the right in the output window. The instruction in Python to print something to the screen, not surprisingly, is just print. So go over there and type print. Don't hit space. Now, we're going to go slow here because there's a chance with almost every single line of code that we're going to write to teach you some really important fundamentals. So here's one of the first ones. We have this instruction in Python, it's called print. Now, we want something to print out on the screen. So it's not enough to just run this instruction called print. We have to give it some information. We have to give it, what's the thing we want printed on the screen? The way you do that with this instruction print is you put parentheses, open and close parentheses, right after the word print. No space between them, just immediately afterwards. And you're going to see this convention a lot in Python, where you have an instruction and immediately after it are parentheses. And inside parentheses, you put information that the instruction needs to do its job. Here, what we need is we just need some text. Now, in Python, as in almost every programming language, the most common way to deliver text information is inside 2 double quotes. So give me a double quote inside of the parentheses. And here we're going to put something to print on the screen. Now, we're not going to reinvent the wheel here. The most common thing you always do when you're starting to learn a new computer programming language is you type hello world. And that is a complete instruction. This line of code right here, that's a complete instruction in Python. We're running the print instruction, and we're giving that instruction the information to be printed. So go ahead and click on this symbol up here and run this, and it'll print hello world on the right. Now, if it did not work for you, give me a 1 in chat. Okay, good, excellent. Again, I know that's really, really simple, okay? So let's move on to something a little more, a little different. What we're gonna do right now is we want to talk about making variables and using them. Remember, a variable is just a way to keep track of information that could change as the program runs. And one of the things that could change as this tic-tac-toe program runs is how many turns have passed. So let's say we only want to give 8 turns. And if there's more than 8 turns, then the game's over. Again, that's a big simplification. The game's a little more complex than that. But let's just say we only get 8 turns, and a turn is both the player and the computer taking a guess. So we want to keep track of how many turns are there. So we need a variable to keep track of turns. Hit enter at the end of this line, and we're going to make a variable. Now, I'm going to hit enter again. I want you to as well, not because we need a blank line, but just to make it more readable. We want some space in between our instructions. Here's the instruction to make a variable. All you do is first give the name that you want the variable to have. We're going to call it turns. That's the name of a variable, and then hit space. And now give the symbol equals, and then a space. And let's just say 1. We've had 1 turn has elapsed in this game. Now, again, I know this is very simple, but there's a couple of really important things happening here that I want to talk about. There's actually 2 things occurring in this instruction. The first thing is we're creating a variable. And the second thing is we're storing some information or data inside that variable. Those are 2 separate things. Now, let's talk about terminology. When you give Python the name of a variable for the first time in your program, you're making that variable, and that is called declaring the variable. Now, here's what actually happens. It's kind of cool. Remember how I talked earlier about the idea that inside the computer are little memory storage devices with millions of little locations where you can store information? When you create a variable, it finds one of those locations on that physical device. The computer finds the location in that physical device and reserves it and gives it a label. That label, in this case, is the word turns. That specific exact location in memory now has a label attached to it. The name of the variable, turns. Here's a way to think of it. Think of that location as like a bucket. And on the outside of the bucket, it says turns. That is called declaring a variable. Now, we need to put information inside the bucket. We need to store some information in that physical location on the memory device. And that's what the symbol equals means in Python. The equals symbol is an instruction in the Python language that says, look at the variable to the left of me and look at the data to the right of me and put that data in the variable. In other words, you're putting the number 1 inside the bucket that says turns on the outside of it. So again, here's that process of putting that data inside the variable is called assigning a value. You're assigning a value to the variable. So there's those 2 words again, declaring a variable and assigning a value. All right, so let's make use of this. Go to the end of the line and hit enter, and let's print off how many turns. print, and we'll do, instead of something inside strings, just use the variable we just created, turns. This print instruction works the same way, except we're not giving it text data. This is important. We're giving it a variable, and it takes the value of the variable and prints it out as text. So when you print it, there's the number 1 being printed out. All right. So let's say we actually have another turn happen. Watch this. You can say turns equals 2. And now do the same command, print turns. I know this is really basic and simple. It's the best place to start when you're learning a program. And look, run it again, and it prints off 2. All right. If your code isn't working, give me a 1 in chat. All right, good. So we've covered an entrance point, the first instruction to be performed. In this case, it's the print hello world. We've covered variables. We created a variable called turns, and we're using it to store how many turns have elapsed in the game. Now, let's talk about control and branching. All right, so we're going to write out the code, and then we'll kind of explain it a little bit. This code is going to provide a way for the instruction to determine whether or not to end the game. And again, this is grossly simplified. The actual game is a little more complex than this, but I don't want to put a bunch of complexity in front of you. Let's learn fundamentals. So our code is just going to say, if the number of turns is more than 8, then end the game. We only give 8 turns for this game. So here's how you do that. You use an instruction called if. And immediately after, you put a parentheses. Now, let's stop for a moment and just talk about this. If is an example of what's called a control instruction. You're about to control the computer and have it make a decision. Based on its decision, it's going to do one of 2 or more possible things. That's what we're going to build in code. In our case, just speaking in plain English, we're saying that if the number of turns is greater than 8, then we're going to print off on the screen, the game is over. And if it isn't, we're going to say, keep on playing. So how do we build that? Well, you do that by using this control instruction we have on the screen called if. And what you're going, again, if is another of these instructions that needs some information to do its job. Now, before, when we used this instruction called print, the information it needed to do its job is some information, some text information that could be printed on the screen. That's not what the if instruction needs. It needs something very special. It needs what's called an expression. Now, not to get all nerdy about math, here we're dealing with an expression which is something that's capable of being determined whether it's true or false. That's what expression means here. Something that is either true or false, no in between, no maybe, no gray area. It's either true or false. And in our case, we're looking at this variable called turns. And if it's more than 8, then the game's over. Here's how you write that. Go inside. We're going to do this slowly. Go inside that parentheses. I want you to hit the space bar. And I want you to hit the greater than symbol. It's just to the left of your shift key by a couple. And then hit space. All right, now let's talk about what's happening here. This greater than symbol is actually an instruction in Python. This tells the computer to do something. And here's specifically what it tells the computer to do. Look at the data to the left of this symbol and compare it to the data to the right of this symbol. And if the data to the left of this symbol is less than, or sorry, if the data to the left of the symbol is greater than the information to the right, then decide on true. That's what it means. Let's write it out and it'll be a little more obvious to you. Go back to the right next to the parentheses and let's put our variable turns in there. See if I can spell it right. And let's go right before the last parentheses and we'll put 8. Now, again, let me say what this greater than symbol is. It's an instruction and it says to Python, it tells the computer actually, compare turns to the number 8. And if the value of the turns variable is greater than 8, then what you're feeding into the if instruction is the value true. And if not, it's false. So let's build this out. All right, good. So that we talked about this idea at the beginning of control and branching. Well, if is a control instruction. What's branching? Remember I had said that with this if statement, this if instruction, we're going to control the computer to do one of 2 or more possible courses of action. Those possible courses of action are called branches. And all they are is instructions that will be completed or not completed based on the control instruction. Let's write it out and you'll see it a little more easily. At the very end of this line, for me, it's line 11. I want you to put a colon. Now, here's what the colon means in Python. This is actually pretty important and kind of cool. You use a colon at the end of the line when on the lines following the colon, like underneath the colon, you're about to list out instructions that are only going to be performed under very specific situations. You're going to list out one or more instructions that only get performed under exact conditions. Everything else, all these other instructions, they just get performed no matter what. But the instructions we're about to create only get performed if the value of turns is greater than 8. So how do we set those instructions apart? How do we tell Python, hey, these certain instructions are the ones that you only do if turns is greater than 8? These are the instructions you do only if the condition inside these parentheses is true. Well, the way you do that is by indenting the instructions below this by a couple of spaces. Watch what happens when you hit enter. Our handy dandy code editor automatically, you can see it indented the cursor 2 spaces over because it's a friendly editor. Now, every instruction that we write that's on this line or the next lines, every instruction we write that's indented by 2 spaces only gets performed if turns is greater than 8. So we're going to keep this real simple. All we want to do if turns is greater than 8 is we want to print out to the screen game over. So you do print and you do text game over like that. I'll let everybody get caught up. Now, that's only one possible course of action, though. What if turns is not greater than 8? Well, let's handle that. I want you to hit enter. And this part is really important. In fact, this next thing I'm going to cover, failure to understand this can be one of the most frustrating things when you're just learning Python. We're about to use another control instruction, and that control instruction is called else. But we don't want to start typing that instruction where the cursor is right now. Why? Because where the cursor is right now is where the computer is going to look for instructions that are only going to be performed if turns is greater than 8. We want to put this next instruction back at the beginning. Sorry. Like that. This is where we want our next instruction. We want it to be outside of what's here, what's indented. By the way, the instructions after this colon, the instructions that are indented, they're called a code block or a branch. All right, so let's go back to here. We have another control instruction. It's called else. And then a colon and hit enter. Look at the way our code editor helped us. It's automatically indented. And now you can kind of see the logic of what we're building just by reading the code. It says, if the value of turns is greater than 8, then print this. Otherwise, or we're using the instruction called else, let's do what's going to be on this line right here. Well, what do we want to do right here? Let's just print keep playing like that. Now, I want everybody to put into chat. Don't run the code yet. Put in the chat, what do you think is going to print out on the screen when we run this code? Keep playing, keep playing, keep playing. Here it says nothing. Let's run it. Everybody run it. And it says keep playing. First it says hello world because of this. Then it says 1 because of this instruction. Then it says 2 because of this instruction. And then I know this is going to be, for some of you, this may seem overly simple, and I apologize in advance, but let's just talk through it again. Remember, a computer does 1 instruction at a time, and it does them in order. So it did the first instruction, and then the second one here, and then the third one, so on. What does it do when it gets to line 11? This is how the computer thinks. It sees the instruction called if, and it knows that there's a condition that could be true or false following. So it looks at the condition. It looks at the value of the variable called turns, sees it as 1, compares it to the number 8 or the quantity 8, and sees that 1 is less than 8. And so it says, oh, that's false. So I am not going to do what's in the next code block right here. I'm not going to do that. Instead, I'm going to continue right here. And this next instruction says else, which essentially means otherwise, do what's in my code block. And here is that code block. That's the decision process. Now, when you start building complex programs, they can have a lot more instructions in the code block, and they can maybe have a lot more complex conditions inside here, but they all obey the same rules. You evaluate whether something is true or not. And if it's true, then you do one thing, and if it's not, you do the other. That's how this works, and that's how you force your computer program to make a decision. All right. Any questions so far? I'm going to look at chat real quick. Anybody got any questions? All right. Now, let's talk about this whole concept of subprograms. It's one of the 5 basic elements of any computer program. We talked about it a little while ago. In Python, the concept of subprograms absolutely exists, but we call them functions. That's the word in Python. They are a mini program that your greater program, your main program, can use whenever you need it. So let's make a mini program. Let's make a function. In this case, we're going to keep it simple. We're going to make a function, a mini program, that will do this over and over again whenever we need it to. That will check whether or not the game is over. So let's make a function. In Python, the instruction to create a function is def. It means define. Now, in this case, you hit space. What follows the def or define instruction is whatever the name for your subprogram that you want is. Whatever the name of your, again, we call them functions. In this case, we're going to call this check turns. We're going to check how many turns have elapsed. And if it's more than 8, we're going to shut the game down. So let's talk about this next thing. Look up here at the top when we first used the command or the instruction print. And remember how we talked about the fact that in order to do its job, this instruction called print needs some information. And so we put that information inside of parentheses. Well, now let's talk about what we're doing down here when we're making this function called check turns. When you make a function in Python, you get to decide or determine whether or not that function needs to be given any information in order to do its job. And the way you do that for a function is you put open and close parentheses right after the name of the function that you're creating. You have to do that all the time. Sometimes the function you're building doesn't actually need any information, but you still need to put the parentheses there. So In this case, we do need this function to be given some information. In order to tell whether or not the number of turns is too big, we have to give it the number of turns at the moment we call the function. So we're going to put inside these parentheses what we call arguments. An argument is the information that a function could take to do its job, could receive to do its job. So in this case, we're going to give it a variable called turns. But again, I should spell it correctly. Now I want to clarify what we're doing on this line of code. We're creating a function that could be used in the future. We're just creating potential behavior. We're creating a mini program that could be used later on if we explicitly tell our program to use it. All right, so we have the instruction define, which sets about the process of making a function. We have a name for our function. It's check turns. And we have an argument inside the parentheses to give information to the function. Well, now we're ready to put the instructions inside the function. So give me a colon. And again, this shouldn't be a shock. When you hit enter, it'll indent by 2 spaces because inside these next few lines, which are called a code block, is the set of instructions to be performed only when we ask for this function we're making to run. So what are those instructions? Well, we kind of have them. They're right up here. We're going to do the same thing every single time we call this function. So let's type those out. We do if turns greater than 8. If. Maybe you should spell if, Eric. And then we're going to print game over. I want some exclamation points in there. And then we're going to do else. Now make sure your code looks exactly like mine. Print. Keep playing. I want some parentheses on this. Now I'm going to pause there for a moment for everybody to get caught up. Check your indentations and make sure you're indented the correct number of spaces. All right. If you're not done, give me a 1 in chat. If you're not done writing the code, give me a 1 in chat. Okay. All right. Now, I'm going to teach you one other cool thing. I don't normally do this. I think it'll be helpful. We have this section, we have this control and branching setup that we made. I don't want to use that at all. I want to take that out of my program. But rather than delete it, I'm going to do what's called commenting it out. That means turning it into a comment. Comments are data inside your program that is not an instruction, that doesn't tell the computer to do anything. It merely gives you and your team information about the program. And the way you do a comment in Python is you use the hash or sharp symbol. So I want you to put a hash or sharp symbol at the front of every one of these lines. Like this. Do that. These 4 lines should all have the sharp symbol, the hash symbol in front of them. Okay, so we are no longer using this control and branching thing. Instead, we've got this checks turns function. Now, this next question, I'm going to warn you, is a trick question. You've been warned. I want everybody to put into chat what they think is going to print over here on the right. What's the last thing that's going to be printed? Put it into chat. What do you think is the last thing to be printed? Farouk, you got that right. Everybody else, I want you to take a guess. What's going to be printed when we run this? Don't run it. All right, Robert, that's wrong. Dan, that's wrong. I understand why you guessed it. There's nothing wrong with getting it wrong. I just haven't taught you this very well yet. Give me some more guesses. Adrian, that's correct. All right. All right, everybody run it. Now, we got the print hello world. We got the print turns when the turns variable was equal to 1. We got the print turns when the turns variable was equal to 2. But even though turns is equal to 2, and we know that 2 is less than 8, we didn't print game over. Can anybody put in the chat why they think it didn't print game over? Or anything for that matter. It didn't print game over, and it didn't print keep playing. Somebody put in the chat why they think that it works that way. Yeah. Farouk, that's exactly right. Adrian, that's exactly right. And I like it because both answers are right, and one of them actually gave the exact right terminology. Farouk said, because we didn't ask for the function to run. This is actually a super, super important concept. When you make a function in Python or any computer programming language, when you make a function, all you're creating is potential behavior. You're making a set of instructions that could execute, that could be performed only if you ask for them to be performed afterwards. That's what a function is. A function isn't do this work. A function is here's the work to do if it's requested. It's a super important distinction. A function is the definition of, it's defining potential behavior. So, and then Adrian, using the perfect terminology, he says we haven't called the function. So, fine, Eric. So we have this potential behavior. How do we ask for that behavior to happen? Well, everybody hit enter. Remember to go back to the beginning there and hit enter again just for readability. The way you use this function, now that you've defined it, now that you've built the function, now that you've defined some potential behavior, the way to actually get that behavior to happen is simply by printing out the name of the function, check turns, and giving it some information. Let's say that only 4 turns have passed. Now run it. And look, it says keep playing. Why? Because when you give Python the name of a function that you've already defined, and you give Python any information that function needs, it goes up to the definition of that behavior. It goes up to the definition of the function, and now it actually runs the code. It takes the value you put in this case, 4, and it runs this code right here using that value that was passed into it, using the value 4. So in this case, inside this function, this argument of this called turns was equal to 4. And 4 is definitely not greater than 8. So it did not do this code block or branch. So it ended up doing this one. Well, let's do it again. Go to the very end and let's call this check turns again. But let's say that 9 turns have gone by. Run it. And now you can see there's the first call to the function where we use the value 4. There's a second call, which is why it says keep playing. But then there's a second call to the function where we use a value of 9. And of course, because 9 is greater than 8, we execute this code block and print game over. Now, Any questions so far? And now I'll show you something really cool. We don't have to pass in a number explicitly. We can pass in a variable. Let's call it again. And let's pass in this variable turns right up here. When you run it, because 2 is less than 8, we print keep playing. And that's where you see the combination of variables and these subprograms or functions, as we call them in Python, can get really, really valuable. All right. Any questions? Okay, so let me see. Oh, Robert has a great question. He says, can you call the function before its definition or only after? Well, I know what the answer is, but let's have fun and do it. I want everybody to delete these 3 ones down below. I want you to go to above the definition of check turns, and let's try to call check turns. And we'll pass in, say, a value of 12 and run the code. And you get an error. Why? Because on line 16, see, we have this file on line 16. When we are calling check turns with a value of 12, it says, you haven't defined what check turns means. So it was a great question, Robert. And the answer is that no, you absolutely can't call the function until after you've defined it. Great question. All right. Now, Baruch says variables don't have to be defined in Python like functions. They don't need to define instruction in Python. And this was just a choice that the designer of the language made. When you want to create a variable, you just, as we see here on my line 3, you just put the name of the variable. Nothing special is needed. Before we hit line 3, the variable turns doesn't exist. The moment we do line 3, we bring that variable called turns into existence, and we also assign it a value. So no special instruction or anything. Farouk, does that answer your question? Or was there something about that I didn't get? Awesome. Great question, Farouk. All right, let's get everybody the code. Okay, Gracie, can you put the link to this file into chat for everyone? Okay, grab that chat, and this same document I'm looking at will open up for you. Grab that link in chat. And I want you to copy all this code. Just click in there and do a Control-A, Control-C, or if you're on a Mac, Command-A, Command-C. Copy all that code and go back to our code editor and delete everything and paste in the code. And I want everybody to spend a minute playing the game. See if you can win a game of tic-tac-toe, and then we'll move on after that. I'm going to try again. I think if I go B2, that gives me the best chance. All right. A3. C1. I win. Okay, good. All right. If you're not getting the program to run, give me a 1 in chat. If it's not working for you, give me a 1. All right. Everybody go ahead and stop, and let's look through this program code and see if we can identify some of the things we've worked on tonight. Go to the very top of the code, and I want to explain this Python instruction called import. We didn't cover that so far. Here's what import does. Import tells the computer to locate a file on the computer, in this case, with the name random. It locates a file that you've already installed called random, and that file is something really special. It's called a library. What's a library? It's a bunch of pre-made code. It's actually really cool. Someone else took the time to write a bunch of Python code, usually centered around a certain kind of functionality. And you can get that file with all that Python code in it, and you can download it onto your computer, and then you can tell your computer to grab the contents of that file, and you can use the contents of that file in your program. That's what import does. It imports that whole library, that whole set of pre-made code. In this case, the random library is all about generating random numbers, which probably isn't a surprise given its name. We have another library we import that we downloaded. We didn't do it. It's all part of this online platform, which is pretty cool. This library is called time. Not shocking. It has everything to do with like working with time, making a certain number of seconds go by or whatever, right? So that's the first thing we do. But then I want everybody to pay attention to this. This next thing is kind of interesting. Remember how I said that every computer program has a first instruction, the first thing that'll be performed? Well, the most important way to think with this is that the first lines of code in the program may not be doing any actual work. And what you're really looking for when we say, quote unquote, the first instruction, is actually the first line in the program, the first instruction in the program that does any work. That's what's real valuable to you as a software developer. Why do I bring that up? Well, check this out. Let's see in this program, where's the first line where we actually do some work? It's shocking. The first thing we see here is that we're defining a function. We did that a little while ago. This function is called print board. The next thing we're doing after we've defined that function, we're making another function called check win. Now, this is a little more complex than our check, isn't it? But fine, there's a function called check win. And then there's another function called get computer move, and another one called get user input, and another one, and another one. None of these are doing any work because they're just defining functions. They're defining potential behavior. The program hasn't done anything yet. And here's another one called tic-tac-toe. Well, there's a comment that says this is the main function to play the game. Well, check this out. Go all the way to the bottom and look. This is the actual first instruction. And the first thing really that does any work is where we actually just call the tic-tac-toe function that we defined up here. We call this function. Now, from inside this function, it will call other functions. Look at this. We call get user input, a function that had previously been defined. And then we call a function called print board. We have a function called, we call a function called check win. So all of those can be called from within this tic-tac-toe function. But the first point in this entire program where we do any actual meaningful work is actually the final line of the file. That's where it starts working. That would be helpful to know. It's important to think with what the first instruction really means. All right. And you'll notice that inside here, we're using a lot of the same things that we did before. We're creating variables. Here's a variable. We're assigning it a value. Now, some of this is more complex, but you do know at least we're making a variable. Clearly, this is some sort of condition, like control and branching statement. And it's got a colon, so everything after this is what we call the code block, the stuff that's only going to be performed if this is true. So you can start to read through this, and even though some of it may be beyond you at this point. If you're very new to coding, you can at least see the basic constructs are being used: variables, controlling branching statements, and subprograms. They're all in there, and that's actually all that's in there. All right. Now let's go back here. Okay. So we did our coding. You have a copy of the code there, by the way. It's for you. Okay. Now, we're doing okay with time. Anybody have any questions before we move on? I'll watch chat here for a second. All right. Now, I got something really cool for you. Dan. There's a lot of people in the class who aren't members of the Tech Academy. So I will tell you that we found the fix. It's going to take a few days to implement. It's really complex, and there's about 600 videos involved. I know for most of you that means nothing or sounds like random gobbledygook, but one of the students in the class is attending the boot camp, and we have a problem with some videos, and so he's asking for an update on that. So short version is, yes, at about 10 o'clock last night, after a bunch of feverish coding, I figured out how to solve it and wrote out a sample program that worked, and now we have a bunch of migration to do. So that's the update. Does that help, Dan? Awesome. Excellent. Okay. Oh, love this. Farouk says, what actual real-life programs is Python used for? Well, you know what? First of all, I'm going to give you broad categories, and then we can look at some specifics. I've seen Python used for building big giant websites, for building computer games. I've seen it used for building programs that process data. Like if your company has hundreds of files that come into your headquarters overnight from all of your different, say, retail locations, I've seen Python be used to make programs that'll read through all those files, extract important information, and dump it into a database. Like all kinds of things. You can do so much with it. But let's have a little fun here, because fun is always nice. And watch this. Let's give ourselves some, where to go. Where'd my chat GPT go? Oh, it's right here in front of me. Okay. Let's grab ourselves some chat GPT action here. Do a new chat and say, what are some well-known applications that are built using Python? I don't want types. No. I don't want types of programs, but actual commercial programs that many people would have heard of. Instagram, Spotify, Dropbox, Reddit, YouTube, Quora, Bitbucket. So I hope that answered both of those questions, Farouk. Is that good? Yeah, that was a great question. I like that. Yeah, Python is very popular for a reason. It's pretty easy to learn. It's actually very powerful despite being easy to learn. And it's been around for so long and is so well maintained that you can use it for extremely important programs that serve millions and millions of people, and you'll be fine. That was a really good question, man. All right. Now let's move on. We're going to get to your free gift, right? I've got something really cool to tell you about. So a bit more about like who we are and what we do. Like I said, at the Tech Academy, we do boot camps, but we have 12 online boot camps, and they cover the wide gamut of technology subjects, including artificial intelligence, which is pretty important. Thank you very much. Computer programming, website development, cybersecurity, design, data science, video game development, mobile app development. You can see all 12 of them here. In fact, we have more certification programs than any other coding bootcamp on earth. And while I could talk for a long time about how these boot camps are put together, because it's over 10 years of work and experience in these, I'm going to keep it very simple. The boot camps are self-paced, but also instructor supported, which is cool. They're flexible. Students set their own study schedule, and then you can enroll any day of the year. The content on the boot camps is very well-rounded and really in-depth. The boot camps are affordable. The boot camps include job placement training and job placement assistance from very, very skilled employment experts. Most importantly, they're designed for absolute beginners. No technology knowledge or experience is required, so you don't have to be a nerd to get through these programs. And who are the programs for? Anyone looking for a better career. Technology is a great industry to work in. There's remote work opportunities. It allows for better work-life balance, and technology pays really well. I can tell you that based on 35 years of experience, it pays well. We consistently land on every major best coding bootcamp list out there, which is pretty cool. Our average review rating across all major bootcamp review websites is 4.8 out of 5 stars, and that's based on student and graduate feedback. People who are very familiar with our product rate us really, really well. So why work in tech? Well, it's a couple different things. It has excellent work-life balance. It allows for remote work, which is pretty cool. It's a really creative industry, and it's one where you can now take a lot of personal pride in your work. And it is a stable industry that pays really well. And as long as you keep applying yourself and learning and getting more skilled, there are regular increases in pay, which is pretty cool. That said, there are some barriers to entry to doing a boot camp. Not going to lie. There's 3 principal things. There's money. Boot camp tuition can cost thousands of dollars. Now, what we've done to solve that is we have multiple financing options, including a very large upfront discount. I'll tell you about that, more about that in a moment. And there's monthly payment options, even monthly options for people that have no credit or bad credit. But the truth is that doing a Tech Academy bootcamp is an investment in yourself. You're giving yourself a set of skills that are highly in demand in an industry that's only getting bigger and bigger and bigger for the last 35 years, right? And it's a skill that pays well. So that's one barrier, is the money. Totally understood. Another barrier is time. There is a lot to learn, and it needs to be done in a short period of time. So some boot camps handle this by teaching people what they call cohorts, just one big giant group of students, and they all start on the same day, and they move through the curriculum at the exact same pace. I can't stand that approach to technology learning personally, right? Also, some boot camps require you to attend in person, all as a way to try to handle this time problem. What we've done is, 1, we made our programs all online. 2, you can set your own study schedule, which means 3, part-time study schedules are allowed. So you can study concurrently to holding down a job or going to school. So that's how we've kind of handled the time problem, right? But finally, to get through a boot camp, you do have to have some technical interest or ability. Now, just based on the questions and some of the answers shared earlier, it seems like most people, or all people at this class, have some interest or ability in technology. But there's a chance that for some of you, you may have tried to break into tech or study some of this stuff and found that some of the materials you're studying seem too hard. I could talk to you for a long time about some of the reasons for that, but I'll tell you this. It's not you, it's the materials. The problem is that some technology educators assume too much prior knowledge on the part of the student. We don't do that. You don't have to be a nerd to get through our programs. You don't have to have any technical background to enroll and succeed. So I have some questions for you. Are you working a dead-end job? And I don't mean that in a disparaging way. Let me clarify what I mean by a dead-end job. This is the kind of job where whether you're happy in it or not right now, when you flash forward 3 years, 5 years, 10 years down the line, is there an income ceiling? Is it a kind of an industry that only pays so much, like they'll never go above 100K or whatever it is, right? Or there's just, when you project where you're going to be in 5 or 10 years, it's not going to be enough for what you want. That would be a dead end job. Not like it sucks right now, but you're looking to the future and it might not meet your needs. Or maybe you're even unemployed. Perhaps it's important to you to work from home, and you're working in an industry where that kind of thing just either isn't allowed or physically won't even work. Like if you're a mason, a bricklayer, you can't work remotely, right? Or maybe you just want more time with your loved ones, that work-life balance thing. The big question is it time for a career change for you? And I know that for everybody on the class, some people in the class tonight, that might not be true, but if it is true for you, if it is time for a career change, the Tech Academy is the solution. We're career change experts. That bridge you see in our logo is there for a reason. It represents, a bridge that will be a route into technology for everyone. And at this point, we have over a decade of experience in helping people break into tech. Most Tech Academy graduates make $30 an hour on average in their first job. That's $60K a year, which is pretty cool as an entry-level worker. And we have over 1,000 graduates working in tech now, at everywhere from small businesses to big places, technical positions at Nike or Facebook or Disney or Uber or Epic Games. So as a reminder, we have open enrollment. You can start anytime. Now, this part's pretty cool. We experimented with a special offer about a month ago, and it worked, and we refined it and tweaked it a little bit. So for July only, we have some very specific incentives, some enrollment gifts, if you can figure out how to actually sign up in July. Specifically, if you pay up front, there's a full 50% tuition discount. Also, by the way, if you pay up front and you need a laptop, if you're in America, we'll send you a refurbished laptop. For July enrollments, there's no sales tax. It gets paid, we'll pay it, but you don't have to. See if I can learn how to operate this. All right. Also for July enrollments, we'll send you physical copies of all of our technical books, our coding books, and our dictionary, which are great resources when you're trying to learn to code. Also, we'll send you a copy of our career planning guide. Now, I know those 3 little words may not seem like a lot. They're huge. This is a very detailed, like 50 or 60 or 70 page long book that my co-founder and I wrote, laying out an exact blueprint for the first 3 years of your career once you break into tech. How do you plan out and execute a successful career over the first 6 months, 18 months, 36 months? What do you concentrate on and when? How do you get that first significant raise? How do you move into something that gives you more responsibility? How do you deepen your knowledge? We laid out an exact blueprint, and it's all in that career planning guide. I've never seen this laid out like this anywhere. And that's why we wrote it, because we couldn't find anything like it. Also, for people that enroll in July, you'll get 90 days of free access to what's called the Accelerator. I referred to the Accelerator earlier, although I didn't give you the name of it, okay? The Accelerator is a standalone subscription service, which is meant for people that already have a little bit of background. Either maybe they're currently going through a boot camp or they're already in tech, as a way to accelerate your career in tech. It's very simple. There's 3 components, and it's powerful. There are weekly workshops with me. There's over 100 mini courses on advanced subjects, and there's over 100 educational videos on advanced subjects. The workshops are the best. These workshops are deep dives into complex technology with open voice and chat and a lot of conversation with me as we just expand your knowledge and your experience. They're very practical. We build real things, right? And those happen every week. They're a blast. And you get 90 days of free access to that accelerator. And almost to the end of this, these gifts are pretty cool. There's also unlimited job placement assistance. This means that when you've gone through the actual core part of the program and you've gone through our job placement course, from that point forward, as long as it takes, we are there with you. Full access to the curriculum, to the job placement specialists, to all the materials about job placement until you get your first job. We're there with you the whole way. And lastly, Oh, I didn't even put it in there. This, okay, I want to go back because it's actually pretty cool. Okay. It's amazing, actually. 1 year of full access to your entire curriculum materials. So even after you've already completed, you're done, right? I got to learn how to do this. There we go. Even after you've completed your boot camp and you're working in tech, you still have full access to all of your curriculum materials. So you can go back and bone up on things and look to it for a reference guide for a full year, which is pretty cool. So if this is of interest to you at all, then you should apply, find out more. Gracie, can you drop this link into chat for people? There you go. When you log in there, it's when you click on that form, real simple, couple fields to enter. And then there's a bunch of cool steps afterwards to learn all about the Tech Academy, who we are, how our educational approach works, what the classes are in detail, what order they're in and why. Everything's in there, right? Videos and articles. There's even an optional step to book a call with our admissions staff. So again, even if you don't think maybe you're going to start in July and you just want to find out more, you owe it to yourself. Click on that, find out more. And if you do figure out how to roll in July, those bonuses are amazing. We did the math on it. It's around $12,000 to $16,000 in savings in July. All right, I'm going to give people a second while I take a sip of water, and then we'll get your free gift. All right. Okay, so I also want to let you know that we have a referral program. Our graduates love us, and they've been referring people to us for years. So they're one of our top enrollment sources. So years ago, we put in place a commission payment for referrals of 5%. If there's people that you think we should be talking to that might be interested in the school, if you give us their contact information and they enroll, we'll cut you a check for 5%. I'll show you how to do that in a minute. I am only going to go over this really quickly because we already mentioned it. We have 7 publications, including 3 Learn Coding Basics in Hours books, a coding book for kids and young adults, the Technology Basics Dictionary, thousands of simple, clear definitions, the Project Management Handbook to teach you how to make software, and You Are Not Stupid, Computers and Technology Simplified. So there's all those books there. Now, here's your free gift. It's our Learn Coding Basics in Hours with Python book, an actual physical book. It's really good. We can send you a copy if you're in America. If you're overseas, I apologize, but we can't send you a copy. But if you want a physical copy of this, here's what you do. Gracie, can you drop that email into chat? You'll see this email, books@learncodinganywhere.com. Send us an email at that email address. There it is. And in there, include your name and your full mailing address, and we'll send you a copy of Python. Also, if you have additional questions for me or any referrals, you can include their name and contact data, but that's the email address to use. I'm going to pause for a second for anybody who wants to send us an email to get that book. Please include your mailing address. Every once in a while, someone forgets that, and we can't send a book without it. In just a moment, I'll get you links to see the recordings and all that kind of stuff. All right. Gracie's going to drop the link to our Linktree. If you're not familiar with Linktree, it's a service where you can aggregate or collect all of your links in one place. So click on that link right now and you'll see what I'm talking about. On here are links to our free educational YouTube video playlist, links to our books, our dictionary, links to our upcoming meetups, and links to our social media accounts. So follow us on social media, And please attend our next classes. We'd love to see you on there. And I want to thank you so much for attending, for taking time out. Hope this was helpful to you in some way. And if you filled out that form, please be sure to complete the steps that follow. It's the Tech Academy overview process is what we call it. And again, explains everything about who we are and how we work. So thank you all so much for attending. Love having you here, and we'll see you at the next event. Good night, all.